Alright guys, so now we want to review slope, which is rate of change, and the initial value of a line, but not from the perspective of a graph. So we spent several days on tables and lists, but now let's look at graphs and see if we can interpret those and find those same quantities. The graphs below both have positive slopes, or rates of change. Which one is steeper from left to right? So if we just do the eyeball test from left to right, which is how you kind of count slope, so from the left to the right, the same way you guys read books, you read left to right, so we're going to agree on that order. If you just do the eyeball test, which one looks steeper? The first one, example D, from left to right, or example E, from left to right, which one looks steeper? And if we do the eyeball test, hopefully you see that example D has a steeper incline from left to right. So this one's going to be steeper in comparison to example E. So good. So we can look at the structure and see how it's built and assign it some kind of steepness. What we want to do with linear functions is actually give it a numerical value, actually measure how steep something is. So can you find the numerical value that represents each slope or rate of change? Remember guys, with slope, it's rise over run, or the change of y over the change of x between two lattice points. Now lattice points are points that we know that have integer coordinates. So for example, this point here that I'm pointing at is a lattice point. It's the point 3, 3. If I were to put a point here on the line, that's not a lattice point because I don't quite know where it's crossing. It's like 3 in a little bit. So lattice points are points that we know that cross at integers. So with that, let's go ahead and find the numerical value for the slope of example D. So if I use rise over run from left to right, in this case, I'll just start at this point. To reach from this point, if I rise, and then I run across to reach the next point on the line, I make a little slope triangle. Here I rose 2, and I ran 1. And I can do this over and over again, so I can do another one. So I can rise, and run again, and I'm going to have the exact same rise 2, run 1. So when I find that, the slope is going to be the rise, so it's the rise over the run. Think of like the little slope triangles. So in this case, it's 2 over 1. So my slope, which we're going to use with the variable m, is going to be 2 over 1. So I'll put that there. Now to find the initial value, the initial value basically is where x equals 0. So when I look at the y-axis, you'll always find the initial value at the y-intercept. So this will always be the point where the line crosses the y-intercept, or the y-axis. So in this case, that's going to be at the point -3. So here at -3, this is my initial value. So here it's going to be the point 0, -3. Now if you make the connection from the graph to the table that we've now spent some time on when you find patterns, in this case, let's first make the connection with the starting value. We know that we find the starting value where x is 0. So notice how in this case, if I look at where x is 0 here, y is -3. -3. Notice how that does match what we computed here from the graph. So there's a connection between the y-intercept and then the starting value on the table. So that's that. As far as finding patterns goes, now when we find a table now, we have to be careful because we need to find the change of x and the change of y. What that means is this changes the pattern. It means the pattern. Okay, this is just the patterns between the two lists. And you're good at patterns. For example, to find the pattern on the x terms, just consider how does x change from term to term. So from -1 to 0, you add 1. 0 to 1, you add 1. Then you plus 1, plus 1. So the change of x, or the pattern of x, is +1, +1, +1. So that's good, it's consistent. Now what about y? So how is y changing as we move along the table? So the pattern here is going to be +2, then +2, then +2. And in fact, it holds all the way down. In other words, 5 plus 2 is minus 3, minus 3 plus 2 is minus 1, minus 1 plus 2 is 1, 1 plus 2 is 3, and etc. Once you find both patterns here, then to find the slope, and I'll put here on the side, slope is going to be the change of y over the change of x, which again is like saying rise over run anyways. But here, by finding patterns, the change of y is plus 2, and the change of x is plus 1. So notice how I can find the slope by using the graph or from a table, but they'll be the exact same value given that you have the table and the graph that represent the same function. Lastly, if I know what the slope is, and I know the initial value or the starting value, you can write your equation in slope-intercept form. So to finish up, slope-intercept form is here. Remember, this is going to be your slope, and then the b is going to be your y-intercept. So with that being said, then I'll have the equation y equals my slope, which is 2 over 1, x, and then my starting value is negative 3. So this equation models this table and this graph. They're all connected to the exact same function, but in different representations.